So as Alan mentioned earlier, I'm Galen Jones. I'm the Director of School of Statistics, and I'm also Chair of the Data Science and AI Hub, which is a system-wide initiative. This initiative is aimed at kind of coordinating over 30 different data science and AI institutes, over 30 different degree programs, basically activities across campus and across the other campuses in the system. What we do is really collaborate, coordinate with other units on campus. We don't own a lot ourselves. And so that's kind of what we're here to do, is to amplify conversations like this. And I really want to thank Alan and Michael and the Minnesota Center for Philosophy of Science for helping us put on this today. You might think that I'm an AI researcher. I work on the details of AI in a technical sense, and I help lead a data science and AI institute. So you'd be forgiven for thinking that I'm a real booster of AI, all right? I am, but I'm also recognize its limitations, and I think it's very important to have conversations like this, conversations around democracy issues, impact on society, and so on, because I am worried about some of those things just like everybody else. So it is my distinct pleasure to introduce Carl Bergstrom. Carl doesn't remember this, but I actually emailed him about 20 years ago, okay, because I had become aware of some of his work on misinformation and disinformation and low-quality scientific work. And he was extraordinarily gracious and shared some materials with me that I then later incorporated into some of my courses. And so I've been very grateful to actually get a chance to meet him in person here today. So he's well known for that work. I would say, you know, from my point of view, I'm not a biologist, all right, but from my point of view, that's where I know him from. But he's also been quite active in evolutionary issues that frankly I don't really understand, but I'd love to know more about in biology. With that, I'd like to welcome Carl for the keynote address.
Thank you. Thank you very much. It's great to be here. I've had a great day talking to people, and really appreciate all of you coming out to listen. And what I want to do today is talk a little bit about sort of, general thoughts about AI and science and where this is all taking us, and then show you a little bit of fairly recent, not very, very recent, actually very, very recent in-progress work where we're trying to think about how the sort of incentive structures that balance that set the balance of research activity, publication strategies, all that are going to be disrupted by AI, even in the best of circumstances, so that we can start to look at how our entire sort of scientific ecosystem and is going to be shifted by the presence of these machines. So that part of the work is a collaboration with Molly Crockett and Eamon Duty. That's very much ongoing, and then pretty much everything else I've done in AI is collaboration with Jevin West, who I've worked with for 20 years on misinformation, disinformation, bibliometrics, statistics, lots and lots of things. So, of course, if we look back in autumn 2022, ChatGPT seemed to come out of almost nowhere. Jevin had actually told me in 2019, he'd said, "Oh man, there's this thing called ChatGPT, ChatGPT-3 came out of nowhere. There's this thing called ChatGPT-2, it's completely amazing, and it's going to change the whole world we're in," and I looked at it, and it was completely stupid, and it was like, basically Eliza, but didn't work as well. And I thought, okay, well, whatever, Jevin, forget it. And then, 3.5 comes out 2022 and November 2022, and everything changes. And it really shocked a lot of us, right? It almost seemed like alien technology because it could do so many things that we didn't think we were close to being able to do computationally, or it seemed like a magical helper, right? That was like here from who knows what super intelligence in order to make our lives immeasurably easier. But as Ted Underwood says, despite being quite an AI booster, as in any fairy tale, accepting magical assistance comes with risks. So we got this fairy tale assistant. And as we know in fairy tales, the magic comes with risks, and it's usually when someone overextends the domain of use of whatever magic gift they've been given, right? And so what I'm very interested in is, well, what are these risks? And today I'm going to limit my remarks to science, though I'm tremendously interested in what those risks might be for democracy, for example, or for education, or for being a human being that communicates with other human beings and connects with other human beings in a world where we're still embodied, at least. Anyway, today, large language models like ChatGPT are ubiquitous. They're built right into the computer systems that we use every day. They're being aggressively forced on us by the technology companies because they want the training data. Our students obviously are using them for everything. Many of our colleagues are using them as well. And so what I want to understand, well, is how is this going to change science as we practice it? And I think there's two fundamental ways. One way it's going to change science is they're going to change science by being bad at what they do or by being used irresponsibly. And I'll talk a little bit about that at the start. But they're also going to change science by not being bad at what they do and by being used responsibly. And even those changes are not necessarily going to be all for the better. And that's going to be sort of the discussion of the modeling part of the second half of the talk. So we start out thinking about what LLMs are good at. What are they truly fundamentally good at? People use them for all kinds of things. You can think about the use cases, but I want to draw upon this course that I will go ahead and just promote for 1 second. Jevin and I sat down a year ago when after talking to hundreds of students and colleagues and administrators and employers and so forth, we designed the course that we thought every college freshman should take about AI. And it's a humanities course. It's not a course about prompt engineering. It's not a course about the technology of how transformers work. It's a course about how to be a learner and a student and a human being in a world where AI is becoming ubiquitous. It's all set up to be sort of quick 5 to 10 minute lessons that have nice kind of scrolly telling New York Times story look and feel that the students really like, long instructor guide and so forth for people to teach it. Being used, we released in February. It's being used in about 100 places this fall. So take a look if you like. A lot of what I'm going to show you in the first half of the talk is sort of, content from there or ideas from there that Jevin and I developed together. So if we think about science, right, and the use of science, we can, obviously at least I had a great summary of kind of the various ways that people might think about using large language models in science. There's a really broad scope of uses from sort of search and summarization. Here's some of the tools that claim to do that. Of course, there's these really powerful examples of domain-specific computing. We heard about some of these, and these are some of my favorite use cases. We, of course, have the Institute for Protein Design at the UW, where they're actually hallucinating, using generative AI to hallucinate new proteins to solve problems that proteins have never solved before. You want to do this enzymatic reaction, but you want to do it in oil instead of water. Okay, let's hallucinate it, and then create the, David Baker's created this high throughput. And this is the key part, right? Created a high throughput pipeline to create them and test them to see if the hallucinations work. So, these are wonderful domain-specific uses to these sort of, AI scientist Eric Schmidt's fantasy where, you never even come into the office. And so this is what Sakana AI claims to be able to, in 15 minutes, write a low to medium quality paper of the sort you'd find published in a journal, and they claim that that's going to democratize science by being able to create these at scale, whatever. Okay, so these are some of the things we might do with AIs. What are large language models in particular really good at? I think they're really good at one specific thing. That's what I like to argue. And to describe that, I think I'd kind of go back and think about a previous revolution in computing. There are a few of you here who are old enough to have been watching the 1984 Super Bowl when Ridley Scott's amazing commercial came out. And for those of you who saw it, you can imagine the woman running in with the hammer, and she's going to throw it through the screen here in just a moment. And this commercial was, of course, announcing the launch of the Macintosh the first really broadly, it was Macintosh 128. It was the first broadly used consumer Macintosh. It was the first broadly used consumer system that had a graphical user interface and a mouse and so forth. And what this did by switching from computer interfaces like this is what we all used prior to this, to computer interfaces that used metaphors that we could immediately get a hold of, desktops, folders, a mouse, pull-down menus, all of that. This was a profoundly democratizing moment in personal computing because it became very, very easy. The learning curve got flattened out, and we could and everyone could learn to use machines. And this changed our world. If you don't believe that this changed our world, you are running in your pocket the descendant operating system of this, and you probably look at it by, if you're typical, 4 to 5 hours a day. So that was a transformational change, and I truly believe that LLMs have comparably, and I'm a skeptic, but they've comparably transformed society precisely by revolutionizing the way that we can talk to computers. LLMs let us, the Apple Macintosh met us halfway in terms of allowing humans to interface with computers. Instead of doing a language that worked just for computers, it gave us a metaphor that worked reasonably for computers. But we still couldn't just talk to them. You still couldn't just ask them to do whatever you wanted. Now we can. Now you just literally speak to them in natural language, and that's a profoundly democratizing thing. And that will have enormous changes for society. And where that is what we want them to do, they're amazing tools. It's absolutely amazing that this works. And I think we can really focus on that, and we can embrace that, and so forth. But also, in my opinion, when we look at what large language models are good at, that's it. That's basically it, right? They're really good at letting us talk to computers. But there's a lot of things that we think that they can do because it's like the old joke about the talking dog, or the chess-playing dog, right? The guy's got this chess-playing dog, and somebody says, wow, that dog is really amazing. I can't believe you've got a chess-playing dog. And he says, well, not really. I beat it 2 games out of 3. And that's what these are like. We're like, well, that's really amazing. You've got a thing that can tell you about physics. Well, not really. It's wrong a third of the time, right? So we forget. It's so amazing that we forget that it can do it at all, that we forget that it's not very good at it. And so what it's really good at is an interface by which we talk to the computers. It's not an information retrieval system, right? Here's Google, had unbeatable monopoly on search technology. How many U.S. presidents graduated from the University of Washington? For 25 years, it got that question right. Now it says that there were 4. Only one of them was actually alive after the founding of the university, and it was only for 90 days. That was John Tyler. Not to say that they're terrible for everything, right? There are certain search things that they can do, but they are not an information retrieval architecture. This is not what anyone would do if they were trying to design an information retrieval system, would be to code up a trillion-dimensional matrix that's sort of somehow compressing an unknown corpus of information and then pull things out through a transformer architecture. That's not information retrieval. But that's what we're being told to use it for. And it is good for certain things, right? You got a fact that's on the tip of your tongue, you can't remember, like, God damn it, what was the guy who wrote Moby Dick? Okay, fine, it's good at that. Google is too, it's maybe even better. Figure out the right search term for a question is fantastic, because here you really do get to talk to the computer in common language. You say, oh yeah, hey, I remember from college math that there's a generalization of the term of the concept of averages that includes the geometric mean and the arithmetic mean and the harmonic mean. What's the generalization? And it'll tell you what it's called, and it'll give you the formula, and it's quite useful for that, right? And you wouldn't quite know how to phrase that query for Google, but it'll do that quite quickly and easily. It's great at telling you what people tend to say, because it's trained on what people tend to say. But in general, it's not that great. One of the other problems, right, as an information retrieval system is they're highly inconsistent. I would never design an information retrieval system. I designed information retrieval systems for a while, trying to do scientific search in the 20-aughts. I never would have designed one, or at least thought it was a success, if I asked it the same question 3 times in a row and it gave me 3 different answers. It's a very poor information retrieval system. They're not machines that are built to reason. There's no underlying, reasoning module. There's no underlying mathematical module. The reasoning, where it appears to be there, is somehow emergent in ways that we don't fully, properly understand, and have a very difficult time editing and debugging. And they're, as I mentioned, they're not replicable. They give, if we're thinking about using them in a scientific pipeline and we're worried about reproducibility, we don't necessarily want to use a system that gives a different answer each time. And giving a different answer each time is something that's very, very hard to get away from because of the issue of the temperature parameter in large language models. Large language models do not, they're text prediction, but they don't always give you the most likely next word. If you have them always give you the most likely next word, they seem very stilted and they loop. And so one of the things that's built into all of these models is a temperature parameter, which gives you, sort of orders the words by probability, and it says, well, how likely am I to pick the most likely, second most likely, third most likely, fourth most likely? And you've got to turn that up so that it's picking from down the distribution a reasonable amount of the time in order for it to generate text that seems reasonable, that's useful, that seems like you're conversing with a human agent, and so forth. And at least in my own experiments playing around with Llama and so forth, when we were trying to make it more reproducible by pushing the temperature parameter down to 0, you really run hard into these limitations. So you're dealing with systems that are fundamentally stochastic in ways that might be okay for a collaborator, but wouldn't necessarily be what you'd want in a scientific instrument, for example. And of course, they're absolutely not peers, right? There's a lot of talk about how they might be collaborators. We could think of them as collaborators, think of them as having a smart graduate student, how we could outsource peer review to them, but they're not our peers. And so, here's just an example. This is a company that tries to use them for peer review. This is a piece that actually Nature ran telling you that you should use AI to peer review your papers. It says, and the guy actually says, I peer review all my papers in 30 minutes. Using AI, and Nature ran the piece, so we had to write a response, talking about, some of the fundamental problems with that. I'm complaining about some of this stuff, and one common response that you get is people say, well, it's all right, they'll get better, and they will get better in various ways, but it is a very difficult architecture, and we go into this in some detail. You don't need to be able to read all of this, but the idea is just simply that we are looking at systems that are driven by gigantic matrices, of a trillion parameters. It's very, very hard to understand why they do what they do. It's a very interesting area of research, and people are making some progress. It's even harder to figure out, why they fail when they fail, and yet harder to fix the failures. And so, especially by changing the fundamental architecture or altering the weights, the failure fixing you tend to do by doing whack-a-mole on either pre-processing with the sort of the prompts that go in, or post-processing with sort of checking the output that comes out. And so we can't debug these systems the way we debug conventional software programs. The system keeps doing something that's undesirable. We can't go find that source of the bug and change that. And so the process of, advancing these technologies is different than the process of advancing other software technologies. It doesn't mean it's necessarily impossible. There are a bunch of other problems we could talk about. We could talk about, exhausting the training data and so forth. And I think there are reasons to be concerned about the long run future of this. But in any case, it's going to, I don't think we can confidently assume that because they were such a big surprise in 2022 that we're going to continue to see inevitable growth in all of this. And in fact, what I expect these systems to do, what I expect large language models to be doing in our world within a few years, and as the bubble settles down and as people figure out how best to use them, they are very, very good at letting us communicate with computers. So I expect companies like OpenAI, if they're able to stay afloat, will survive the same way Google did. Google did not stay at top of search by just making PageRank a better and better algorithm. Google stayed on top of search by using the data that they had coming in to build a triage system where the queries come in, and then they farm the queries to one of 1,000, ballpark different modules that is query specific and has been trained using different kinds of domain specific knowledge to give you the answers that you want. They're not doing that now. Now they give you bullshit from Gemini. But before they started doing that, that's how Google operated, and OpenAI, I think, will do the same thing. And there's a lot of potential for this. This could be a very, very useful knowledge resource for people, right? Where you can talk in common language, low barrier to entry, good triage system, domain-specific AIs doing things under the hood. But I think that's where we're going to end up, not having one better LLM that is just our one-size-fits-all solution. And then finally, as we think about science and large language models, the thing that I find perhaps most dispiriting, and I'll stop the sermon after this and actually do some science, but I had the opportunity, and you were a captive audience, so I had to say this. One of the things I find most dispiriting about the way that LLMs are changing science right now, and the way that so many of my colleagues are incorporating them and so forth. So they're saying, well, they let me write papers faster. I can spend more time. I can spend more time writing grants because I don't have to spend all this time writing up my papers. Or now it writes up my grants too, so I can, whatever it is that they want to do, I can spend more time taking the dean out to lunch or something. But they feed into these Taylorist assumptions we have about science, that the role of science is to create papers, and the more papers we can create, the better. It's like, if we're making televisions, fine. If you can make more televisions for less money, great. If you can make more papers for less money, that's not great, because papers aren't the output of science, right? Papers are a vehicle that we use to communicate with one another and to share scientific findings, but what is actually being produced is this socially distributed knowledge and understanding about the world, and creating more papers isn't necessarily doing that at all. And yet, because of the metricization of everything that we do and the way that what we're rewarded for and everything else, we are very vulnerable to these supposedly time-saving technologies that come in. And yeah, sure, we know it's not quite as good as writing it yourself, but I need to get this extra paper out. I need to do this. I need to get back to the serious work of doing science. And I think it also sort of points at this odd, to my view, set of beliefs that many lab scientists, for example, I can speak to that best as a biologist, have about the nature of what they do, where the time they spend in the laboratory is the time they're doing science, the time they spend, and then it's done, and you figure it out, and then you write it up, and that's no different than filling out your travel reimbursement request forms. The intellectual work is done in the lab. The writing up of a paper is just busy work. And of course, that's not how science works. Writing is thinking. We develop our ideas trying to write. We develop our ideas trying to communicate. And in fact, in the second half of the talk, which is about to start, I'm going to show you a bunch of stuff that I did about 3 in the morning this morning, because I'd been trying to put this talk together, and I fell asleep, and I dreamed that there was a way to prove this more elegantly, and I woke up, and for once it was right, and so then I put it in here, and so I was doing science while I was trying to communicate, right? And I think we all are, but if I'd put this through an LLM and said, here's the model, write a talk for me, this never would have happened. And I think that creativity and that humanity is so very, very important. And this is just to remind me to take a breath, because that's the end of the sermon part, and now we're going to do the research part. So, okay. So what I want to do in the research part, I do want to think, I promised in the title I was going to think about how LLMs disrupt the incentive structures that shape our research strategies and our publication strategies. And that's where I want to go. And in particular, I want to focus on writing. And I want to, because there's many, many different things that LLMs can do, but I want to look at how we use them as communication surrogates, how we use them to write on our behalf. Before I do that, and I realize I've got a broad audience here, the philosophers will find this very, very, probably sophomoric. You could tell me about it afterwards. But I want to but at least you'll know where I'm coming from. I want to give you kind of the way that I think about science and institutions and incentives and actions. So I've always been passionately in love with science since about the time I was 7. It gives us these superpowers that let us understand the universe at scales that are vastly different from our evolved sensory apparatus. So we didn't evolve to have any reason to perceive anything on scales of light years or scales of nanometers. We didn't do or time scales of nanoseconds or or you know, in many, many millennia. But with science, we can create instruments that we work with to be able to understand things like what was going on in the universe in the femtoseconds after the Big Bang, what's happening at the far expanses of the world, what's the molecular basis of life, how is it structured, and then, you know, just to convince ourselves that we're not simply playing some kind of self-referential game with no connection to the world, we can leverage that into all kinds of technologies and fly out here and write a talk and get a little bit upset about the quality of the Wi-Fi while you're hurtling at 500 miles per hour through the sky in a metal tube, and you know, why is it slower than in your house? Or you can, when a pandemic comes around, you can identify the source of that pandemic, have a genetic sequence within a matter of days, and have a good part of the population, at least the part of the population that wanted it, vaccinated within a year and a half. That's amazing, right? And so science is so successful that we often think that it must be like the one true path to knowledge or something. Many of my students think that. Maybe no one in this room thinks that. But it's like if we just sat down and designed science, you know, just from first principles, we'd end up with what we have. But of course, that's not at all what we have. What we have is this highly contingent system of norms and institutions. Here's the longest running, first issue of the longest running you know, scientific journal, Philosophical Transactions. I've published in there, a lot of you have published in there, and we are bound by these traditions that essentially emerged from the way that people with, you know, plenty of money and time on their hands like to spend that time in, or some small subset of them like to spend that time in certain parts of Europe over the last few hundred years. And of course, if bees did science, it would likely look really, really different from what we do, partly because they would have had a different cultural evolution of their scientific tradition, but partly because they would be jury-rigging the rules that they have across a completely different evolved psychology of a completely different kind of creature with different epistemic goals, but also with completely different reward systems, right? So this science that we have is very, very effective, but it is also a very arbitrary, in a sense, result of two evolutionary processes. One, the evolutionary process leading to our evolved psychology, and the other, the cultural evolutionary process that then, you know, sets a set of rules and institutions and so forth across that to allow us to collaborate in this great endeavor of making sense of the world. So, you know, when we ask ourselves what is it that motivates scientists, it's really easy to kind of go to this picture of, you know, here's St. Jerome in his study, and he just, you know, I guess he's doing natural philosophy, and he wants to understand the world, and he's got a lion and a little halo, and it's just, you know, pure inspiration, pure curiosity around the world. In practice, here's my good buddy, Jevin West. He's stoked because he just got a TED Talk. So these are really, really different notions of motivation. Phil Kitcher, who I know many of you know, has lovely phrases for this: epistemic purity versus epistemic sullied. I'm epistemically sullied. Everyone I know is epistemically sullied. Michael Strevens argues it's a good thing that we're epistemically sullied because it gets us to do the boring work that science needs of collecting lots of data instead of sitting in your study with a lion and trying to figure out how the world works. So we're epistemically sullied. And so I want to understand then, well, given that, we're able to start to ask questions about, okay, well, what are the choices that scientists make? What do they do? Why do they do it? Well, why do they do it? And that has to do with the incentives they face. They're epistemically sullied. Where do the incentives come from? From the institutions and the norms around science, right? And this is the fundamental research program of an area known as the New Economics of Science that was founded in the 1990s. The old economics of science was sort of macroevolutionary stuff, macroeconomic stuff. If the government invests this much in R&D, what are the long-term consequences on the growth of the GNP and that kind of stuff? So to contrast it from that, thinking about the sort of microeconomic foundations of the individual decisions that individual scientists make about their research and publication strategies became the new economics of science. It's a little bit narrower in scope than I'd like it to be, but it's but let me kind of lay out the way I think of these pieces coming together, and then I'll give you a little illustration of AI in this framework and how that's changing things in that framework. So we sort of, if we want to take sort of incentives, you know, we're interested in where do these scientific, you know, we've got these incentives. Scientists are responding to incentives. This is sort of what economics is about, right? How do people respond to incentives? The incentives, well, these are coming from norms and institutions. And they may be brick and mortar institutions like the NIH. They may be sort of norms like the priority rule for credit, or what constitutes authorship on a paper, or what even constitutes a publishable unit. So you have these norms and institutions create the incentives. Scientists, respond to them when they choose their research strategies and their publication strategies. Those research and publication strategies are then used to sort of query nature, and that generates our knowledge about the world. And the sort of key thing to notice here is there's a direct link from the knowledge about the world back to the norms and institutions, which we already agreed, if you agreed with me, are more or less haphazardly, randomly, culturally evolved, maybe evolutionarily evolved to work well for our particular species. So the idea is that if we can understand this whole path going all the way through, then we can get a good picture of how science works, why it works. And part of the problem is that different parts of this path have been siloed in different parts of the academic world. The new economics of science is really that vertical business in the middle. You've got the sociology of science over here with the norms and institutions, and then a lot of the philosophy of science is really over here looking at the relationship between research strategies and the creation of knowledge, right? Not that people don't cross over to some degree, but the idea is to try to put all of these pieces together. And so that's how I like to think about all of this. And I want to try to think about how AI is going to affect science in this sort of a framework. That's where we're going. But writing. We're going to talk about writing, of course, and we're going to talk about letting AI write for us. Of course, there's a lot of reasons why we might want to read papers that living beings have written instead of computers. People have written a lot about these reasons, especially recently. They range from the importance of writing in the thinking process to writing as sort of a credible signal that someone has the expertise and the positionality to be able to comment intelligently on a subject, to the sort of importance, we might want to read human written things because we don't want this monoculture. We want the epistemic diversity that comes from hearing from actual people as opposed to one system that might tend to regress to the mean. We could come up with a lot more. But let's sort of set these aside and assume, that we're not going to worry about those as much. People are writing in good faith. There are, of course, plenty of bad faith uses for this, right? So someone already commented about how the archive has had to, I think it was here, it might have been this morning, about how the archive has had to stop accepting submissions in CS for review and commentary papers. So the archive you can only post a preprint there if it's already been published somewhere and is no longer a preprint. Here's a story in the New York Times a couple of days ago about this guy who'd submitted hundreds of letters to medical journals. They'd all been written by AI, and he had gone from sort of never publishing to publishing 100 letters a year through AI. But again, we're going to set that aside. We're going to assume, just for the purposes of modeling, let's assume there's strong enough norms, people are operating in good faith. Of course, I think LLMs write really dreary prose. We talked about that. You can kind of detect when someone's using AI prose, and it's just not. It's not great writing. But imagine they somehow get better and they write beautiful, lush prose. So what I want to do is sort of think about a world where I don't want to complain about LLMs doing things wrong or people misusing them. I want to think about a sort of a hypothetical world where people are using good LLMs in good faith. LLMs are writing good prose, and everyone has a unicorn pony. So what happens in a world like that, right? And I'm going to ask sort of three questions. And the first I'm going to ask about that is, well, which results get written up for publication? How does the presence of LLMs as a communication surrogate technology change what comes out that knowledge end of the picture I showed? What actually gets written up for publication? And to do that, a very simple model. You don't really have to worry about any of the names and the variable names, and I'm not going to do any derivations or anything like that. But just to tell you kind of what I'm thinking about, what are the moving pieces? imagine people are discovering scientific results that vary in value. Some are really high value, some have lower value. Papers can be written up to varying degrees of quality. You can write something really well, or you can write something quick and dirty. There's some effort to writing papers. There's some benefit to publishing papers. That depends on both how valuable the discovery is and how well the paper is written, right? So let's look at effort. So imagine that the cost of writing a paper increases. So here I've got the effort cost on the vertical, the quality of the writing on the horizontal. And just imagine that the better the paper is written, the more effort it takes. Okay, shouldn't be very controversial. Here we sort of have, and so I imagine what's AI doing? It's giving me a big cost savings. So AI with, if I sit down and I write a paper, it's going to take me some time just to write the paper down. And then as I make it better and better, it's going to take me more time. And here I'm just imagining I get a fixed time savings from using AI, right? Don't worry about the fact that these are linear. This is because this is just an ordinal scale, so we don't have to worry about that. We could also, look at examples, and all the results I'll show today would hold for cases where the value of the benefits from AI are sort of saturating. You can write a bad paper with AI really easy, but writing a good paper with AI is just as hard as writing it by yourself. We can do that too. I'm not going to show you those results. So that's the costs, and then there's benefits. And so now we imagine that the benefit, there's more benefit to writing a high-value paper well than a low-value paper. If I've found something really cool and I write well about it, then I'm going to get it into Nature or whatever, and it's really going to be a big splash. If I found something that isn't that interesting and I write it beautifully, it's still kind of limited gains I'm going to get to that, right? So, and you can write this down in terms of derivatives and all of that, but you don't need to do that or think about it because we can just use pictures. So now let's just do the sort of basic economic analysis. You've got these benefit curves here. So you've got benefits that you get from having a high result. That's a really good result, the top curve, or from having a not so good result, a medium result. That's that middle curve here. And then you have the cost of writing it with by yourself, or having an AI write it for you, or using an AI to help you. And again, we're assuming there's nothing wrong with the AI per se. It's just doing some of the work for you. That's it. So how does that change things? Well, we can figure out the optimal quality of writing here. This is just very simple optimization. We're going to just equilibrate these slopes. So the high quality paper gets written to, the high value paper gets written to this quality, whether by hand or with AI help. So you see that there. That's how the high quality result gets written well. The weaker results get written to a lower standard. And with AI, we're sort of in the same place, but it's cheaper for everybody, right? So nothing really that's so surprising there at all yet. But now let's look at you get an even weaker result. Suppose you get a result like this that's really just not a very exciting result. So here's our old exciting result. We get this high quality result. Again, we write that up well, but we get this weak result. The cost of writing it up is higher than any benefit you'd get from publishing it anywhere. There's no quality that would make this, that would put you in the black here. So what would you do? You wouldn't bother to write that up at all. That's a paper that never gets published. That's a result that never makes it out there. With AI, of course, both results get written up because it's very cheap to write with AI. So what happens is these large language models are changing which results get published. Is that a good thing or a bad thing? I don't know. Depends on the culture of the field. It depends on how much these minor results are important. There's a lot of calls for publishing null results. Maybe in some places that's a good thing. In other places, there's too much crap in the literature already. We can't possibly sort through it. And the last thing we need is an influx of more papers. But I'm not trying to make a call on that. What I'm trying to say is that by lowering the cost of writing papers, there are going to be results that weren't interesting enough to merit writing up that now will be written up. So that's one fundamental change, right, that we're going to see in terms of which results get published. Nothing about the LLM being good or bad or anything. It's just cheaper. That's it. Okay, so next thing, this is the part that I was dreaming about and then put in the talk. So if this completely fails, we'll know that I was off. But I had a different proof here yesterday when I flew in. But what happens to the quality of the presentation of research results? And here I'm going to draw upon a theorem in ecology, a very simple theorem in ecology that I can show you graphically, and I'm going to illustrate with this echidna that I met in Australia. And then the theorem is Chernow's marginal value theorem. And what it tries to do is it says for an echidna or anything else that eats food in patchy locations, how long should that animal spend at a patch before moving on? So if it's an echidna, it goes and it slurps up termites, it gets to a termite mound, it starts slurping up termites, and eventually the amount of termites it can get starts to saturate because it's already eaten most of the termites. And so at some point it should say, okay, this mound is exhausted enough, I'm going to go and move on to the next mound. How long should it stay there? Well, that depends on the travel time between patches. And so what Chernow notes is that this echidna is selected to maximize the resource intake on the vertical, the rate of resource intake. So that's the resource intake on the vertical divided by the amount of time spent on the horizontal. So the echidna is selected to get the highest angle here of average resource intake. Average resource intake is just the travel time plus the eating time. So the echidna will choose to stay until he reaches the tangent point to the axis, where this axis is the represents the amount of travel time. If the patches are far apart, this goes way out. The tangent is way out here. He spends a long time there. If the patches are very close, then this is going to be very close. He'll spend a short time, right? So none of that's so surprising. Now we can think about our optimal investment in writing. And so we're going to go back and we're going to think about what we do, what goes into writing up our papers. So first we spend a bunch of lab and research time. I'm using the model of a biologist, right? Spend a bunch of time in the lab doing that. So we kind of do our pipetting and do our stats and all of that. And then without an LLM, at least, we have to do a lot of writing before we have something anyone can even read. So that takes a few days just to get something you'd even show your best friend, let alone send into a journal. And then at that point, you've got something that has like non-zero value. And then the more time you invest in it, and this is the same picture we had before, right? The more just axes shifted, the more time you invest in it, the better the paper is. So the more benefits you're going to get. So we're not worrying in this graph about the value of the result. We're just looking at the relationship between how hard you work on the paper and the benefit you get out of it, right? So what should you do? Well, we already saw with the echidna, right? You want to maximize the value you're getting per time investment, right? Previously, I'd kind of cheated and I'd said, oh, there's a benefit to writing and there's a benefit to publishing and a cost to writing, but I didn't put it in a time context. But that cost for us is time. It's almost always time when it comes down to writing. And so now let's just put it explicitly in this temporal context. So of course, we're going to look for that tangent. How well are we going to write it? We're going to write it, as well as we hit that tangent where this is your lab time and your writing time. So that's without LLMs. Now, suppose we have an LLM. What does that do? That shuts down the writing time. I push of a button, I can get something I can show to my best friend, just dump my data in, say, write this up. And then I can kind of coax it into writing something better and better. This is our assumptions, at least. We're looking at an LLM that actually works, right? And so what it's doing, it's just shifting that time in that direction. Well, what does that do to the optimal? That shifts the optimum point to there. And what does that do? Well, that point always, it's a little theorem, that point always has to be lower than this point. So we get a reduction in writing quality that results from all of this. Okay, so you're not going to write a paper up as well if you've got an LLM. And one way to see that is that the LLM has effectively made your time more valuable, right? The opportunity cost of your time has gone up because you've got this LLM that can do some stuff for you. So you're going to invest less of your time. It's more precious in a task like writing. So you're not going to write things up as well as you were before. Well, unfortunately, the same result applies to your lab and research effort as well. So now, here you've got your investment in research with an LLM, and so you might say, well, that's the best I can do, but you could actually do better if you want a higher rate of return. You could do a sloppier project, a shorter, less well thought out, less well planned project with maybe a smaller sample size or less careful measurements or whatever it is. You write it up less well. Of course, it's a much less good paper. You're way down here now. But your slope, the slope of this lower line is a little bit higher. So you're getting better time return. You can just write a bunch of these bad papers because you've taken that heavy writing cost out of the equation. You don't have to go through that every time you write a paper up. So now you can churn not so good papers. And that's not the case if you have to actually write them yourself. So if you have to write them yourself, now this, if you write it yourself, here's the best you can do if you when you're writing the paper yourself, this here is the best you can do with a fancy paper, a paper you've spent a lot of time in the lab on. This is the best you can do with a paper you've spent less time in the lab on, and the slope's now lower. So what happens is the LLM is doing two things. It's causing us, with LLMs, our papers are written less carefully, and the research is done less thoroughly. Why? Effectively because the LLM is making the opportunity cost of your own time higher. And so you're skimping on both ends of the rest of the process, and you're grinding papers. This is an LLM that works perfectly. This is not an LLM that does anything wrong, right? This is an LLM that removes frictions from the process. But those frictions were inducing certain choices about how well to write something up and how thoroughly to do your research. And when you remove those frictions, you sometimes get problematic things. I'll show you one last thing, and then we'll wrap up. What happens to the research strategies you choose? These were both kind of ex post decisions, right? How well should I write my paper up? That kind of thing, right? But let's look at the actual research strategies in the first place. And I want to think, just because I've done this for the last few years, I've been thinking a lot about high risk, high return research, why we tend not to do it, what are the impediments, what are ways to encourage it, all of that, right? And so I want to think about this problem of choosing an appropriate level of scientific risk for your research. So you might imagine that so what this graph shows is there's sort of, you have results of different value. These are these blockbuster discoveries that are going to get you a Nobel Prize out here. This is the sort of everyday bread and butter stuff that most of us do most of the time. And these are kind of the boring failures that at least pre-LLM we didn't bother to write up, okay? So that's a sort of a low-risk, low-return strategy. You're fairly likely to get something that's publishable. You're very unlikely to win a Nobel Prize off of it. So you might take a strategy like that, or you might decide to shoot after something long shot that might look a little bit more like this. Most likely, it's going to fail entirely. But with some small probability, you're going to get a pretty big result that's going to get you a Nature paper, maybe not a Nobel Prize, but a Nature paper. And if it's easier for you to look at the cumulative plots, here's how the cumulative probability distributions, right? Almost all of the weight, almost probability 1 here with the high risk, high return strategy, you're going to get something that's worth less than 0.4 or whatever. With a low risk, low return strategy, you've got a reasonable chance of getting something worth, 50-50 chance of getting something worth more than 0.4, or more than 0.3, but you're very unlikely to get something awesome. But with the high risk, high return strategy, there's a little probability here that you could get something really awesome. So these are two different approaches that you might take. Now, which approach are you going to take, with or without LLMs? Well, let's look. So your payoff, you do this experiment, you get a benefit, and now you pay a cost to writing it up. So your overall payoff is whatever benefit you get from publishing it minus the cost you get to writing it up. So so if suppose it's quite expensive to write things up, then if you write up, suppose it costs 0.6 to write something up, then right here is sort of your marginal paper. If you write that paper up, you're sort of indifferent between writing it up and not, so your value is 0. This is from our low-risk strategy. If you got something 0.7, you're certainly in the black. You go ahead and write that up, and you get a reasonable little payoff. And you're quite unlikely with the low-risk strategy to actually get something really, really important. With our high-risk strategy here, if you get anything that's out in this tail, it's worth writing it up, right? Anything that I think I can send to science is worth my time writing up to send to science, or whatever. So if you compare, if you look at the area under these two curves, my expected payoff, from the high risk strategy has a lot more area under the curve than my expected payoff from the low risk strategy, because the low risk strategy is unlikely to generate much that's even worth the trouble of writing up. Suppose I let LLMs write up for me. Now the cost of writing up's low. It's 0.1, say. Now most of the low result, most of the results from the low risk strategy are worth writing up with the LLM. I do that. I have some substantial probability mass under here. An awful lot of the results I get with the high risk strategy are between 0 and 1. Most of my high risk stuff just fails. I'm not going to write that up with the LLM. If I do get something from the high risk strategy, great. But now my calculus is switched. Now I have a higher expected payoff. There's more area under the curve here for the low risk strategy than for the high risk strategy. So without an AI, it's much better to, for me to pursue this high risk research program and write up the really cool results I get. With the AI, much better to pursue the low-risk research program, have the AI doing the write-up, and just keep grinding papers out. And because almost everything I do in the lab can be publishable if I don't have to actually pay all the effort cost. And you know what it's like of pulling out your hair for 3 weeks trying to get a paper into, to tell the story you really, really want it to. And so the key message that I'm trying to get across is that LLMs, even when they work perfectly, even when they do exactly the same thing that you would have done, but they just do it for you, they change the research strategies that investigators are going to adopt. They're influencing this very fine balance of incentives that currently, that currently sort of structures scientific activity. And my point is not that this is the biggest impact of LLMs. Or maybe not even one of the bigger impacts of LLMs. But my point is that it's an impact of LLMs. They are going to change science and the choices that scientists make, even where they don't do any harm. And we would do well to stay on top of that with our norms and institutions. Norms and institutions evolve slowly. Technologies like LLMs, as you know, come crashing in and are rapidly adopted. And there's going to be periods of mismatch where the norms and institutions are not well structured with the right rewards and the right incentives to have people doing the things that are leading to the most constructive science once LLMs, even LLMs that work perfectly, arrive on the scene. And that's the point of this paper, is to think about the ways that LLMs, bad or good, or neither, are nonetheless shocks to a system of balances. They remove frictions. Usually removing frictions are good, but there is a good thing, but there are useful frictions in many, many systems, and some of these hassles around writing things up. You tell the same story about writing grants or whatever it is, right? So we need to get out ahead of that and think of that. To finish up, and this echoes some themes we heard during the panel discussion, I want you to just pause for a second and think about the joy of doing science. And really, I'll shut up, really pause for a second and actually think about the last time you felt joy doing science, and think about where was that joy that brought you to it in the first place. Just humor me. Okay. So in Hamburg, there's a new train, world's first automatic driverless train. And it's run by AI. And you can watch a nice video about it. And of course, because we still, for whatever reason, feel like we need a human in a loop, there's a guy who drives the train. The guy does two things. He pushes a button to make the train start going, and he's got another emergency button that he can push to make the train stop. Those are the two things he does all day long. We're scientists. Eric Schmidt has this dream of an AI scientist. Is that the future you want? We get to choose. We're the ones who structure what science will be. So it's up to us. And so that's my talk. Take a look at the course if you like. Thank you so much for listening. Love feedback in any direction. And yeah, thank you all for being here.
Thank you. Lovely talk. It seems to me that your LLM analysis at the end is really a question of gatekeeping. not a question of LLMs, because it is in fact, it all depends on the cost of writing the paper. And to some level that you're happy with.
Yep, that's right.
And so if somebody comes in and writes crappy papers, all of your analysis, if your level of how good a paper you're willing to tolerate changes, your whole analysis comes through exactly the same way, I believe.
I mean, what I'm thinking of is those benefits are not internal satisfaction from having done a good job, but external benefits from having published in places that people care. But if the whole field changes, and the whole field's like, oh yeah, now you can publish.
Right. So I want to come at this because I know gatekeeping has been something that you've talked about, and we talk on social media a lot.
Yes.
A lot of what we've done to prevent what we used to call least publishable unit is we've created gatekeeping, right? So it's very hard to get a paper into Nature. It's much easier to get a paper into PLOS One, right? And what I'm seeing now is, in part of the push against gatekeeping, is to start treating everything more equally. I think, am I correct in thinking that your analysis actually suggests that gatekeeping, that break of gatekeeping is an even larger problem than the LLMs coming in? Because I think your analysis essentially depends on the gatekeeping.
Yeah, you're right. I mean, I think that's a very fair critique. So, right. So if there's some exogenous force that changes the gatekeeping, the same diagrams largely would hold throughout, right? And you could say PLOS One counting reasonably much might be an example. Now, personally, what I think, and this is just based essentially on introspection, which is really hard because you're at a different career stage as the world changes around you. So I can't subtract that out. It seems to me that Nature and Science papers and things like that, while we have had some break in gatekeeping in terms of having more sort of permissible PLOS One venues, Nature and Science, I believe, is worth vastly more than it was when I was a graduate student. It was when I was a graduate student, a Nature paper was worth 2 papers in genetics or 2 papers in evolution, are good society journals. Now the papers in genetics or evolution aren't worth putting on your CV, unless you've got to fill out a page. And I've got pretty good empirical evidence for this in economics, for example, where now the Big Five, you publish in the Big Five. There's no point in not publishing in the Big Five if you're a graduate student. Fascinating.
But that's because economics very explicitly went in and created that gatekeeping Big Five.
They're trying to gatekeep, and so I think, I think it does come down to this, and I think we do have to think about, what is it that we want to encourage the kind of science that we find valuable and fun to read. And so one thing that I'm predicting coming out of LLMs, I can use an LLM in 15 minutes on my phone to write a theory paper that's about as good as the average one I reject from PLOS One, right? So one of the things I think is very likely to happen, I think about theory, like what's going to happen in theory. Because the LLM could do actually the whole, the LLM can't pipette very much yet, but it can totally do the theory, right? Well, I mean, badly. And it can't do it for shit, but in principle, right? It doesn't, you don't need to be embodied to do theory is what I'm trying to say. And so I'm predicting that actually, much as we've already seen in economics, style will become, and sort of flair will become more important rather than less in a number of areas, precisely as a response to LLMs because of the kind of gatekeeping, the necessity of gatekeeping that we're talking about. I don't know what you think of that. Yeah, Yaniv.
Yeah, super fun. I couldn't tell. I couldn't look at the map or whatever fast.
Yeah, sure, it came by fast.
But I could imagine lots. Of different structures of those things, and I could imagine, okay, like you said, maybe we're all going to the Big Five of economics, where the only thing that matters now isn't a cumulative sum of how much your total value is, but like your greatest value or your median value, your mean value, and who cares about all those garbage papers? It's great that you publish these garbage papers, but they don't get you anything, and the cost is so low that we can. So, how sensitive are the results? I don't know if you've had time to look at that. I could imagine. When I saw your picture, I thought you were going to say that once we have LLMs, we're just going to do really high variant science that would, very high risk, high reward because the risks are, are changed. It's really easy to do a bunch of experiments.
No, of course.
And
Of course, these are meant to be illustrative examples of the kinds of directions things are going to go, especially with the risk thing.
Yeah.
That's completely dependent on the choice of distributions. With the results about the directional shifts of the quality of the research and the writing, this basically stems from the fact that your time has become more valuable, and so your opportunity cost has gone up, and so those are pretty robust.
And I also wondered about if it's cheaper to start experiments, cheaper to do them, cheaper to whatever to publish them or not. I also wonder about the probability that an exciting result is true, given that you found it, and if this has some knock-on consequences to the old reproducibility crisis, like are people going to go out there and do higher variance work in hopes of getting one of those winners, and are we going to change our standards for what's significant, what's notable, if it's cheap to, anyways, sorry.
Yeah.
Yeah.
Thanks. I mean, you're totally right to pick up on the fact this was an arbitrary choice of example for the high risk, different distributions will do different things for the high risk, high return example. Absolutely.
So sticking to what you were just presenting here, and I thought it was interesting because you're emphasizing communication as sort of a central role of a researcher.
Yes.
And when I think about that, right, like I think of, let's say, novelists who take great care about the crafting of words.
Yes, yes.
Research, in many ways, it is kind of, if you're lucky, you have a good mentor, you'll learn these skills.
Yes.
But by and large, I would say that for many, it's kind of like, quote unquote, like facts, just communicate the facts. And there's a template that you can follow it, and publish it, right?
Yeah, I mean, unfortunately.
So I wanted to push you to keep on what you were already suggesting, and that is, how would the academy, how would disciplines, how would training change? What is it that we would emphasize? What is it that we would now say our graduate students really want them to learn this in ways that perhaps previously we didn't really?
In a world with LLMs?
Yes.
Yeah. So I mean, I think the great question. Yeah. How do we need to change training? I mean, it gets at the skilling question that a number of you brought up, and this is one of the things I'm most frightened about. It's exactly right, as you pointed out. Like, take the current crop of scientists with their current skills, and give them LLMs. One thing happens. Train a crop of scientists on LLMs. So in 20 years, something completely different happens. So one of the first things we have to figure out is how are we going to create the necessary inducements? I mean, assuming that some of the skills we have now are good ones, and I realize that this does, some people you're arguing don't even have them, but assuming that they're good, how do we manage to provide adequate incentives? And I think about myself as a, first-year grad student where I'd never written a scientific paper before, and maybe in college I would have been able to, most of the time, say, oh, I'm going to write this paper because I need the practice, and I know it's for the practice. But when I wrote my first scientific paper, that shit mattered. Like I had to get that right. And if I thought an LLM would have done a better job than me, I would have used the LLM. And so how do we get across that activation barrier so that students get the practice while doing tasks that matter? And I don't know. I'm really worried about this, right? Otherwise, we're going to, and that's not just for writing. It's also for experimental design and everything else. I do think that we need to push back against these notions of science being an assembly line where you collect data in the lab, write it down according to a formula, and then you used to, cookbook stats it, now you vibe stats it using an LLM, right? And so I think that's not what science is. I mean, science is this extremely collective process of human coordinated shared understanding. It's this social process, and the communication is an intimate part of that. It's not just generating numbers to fill in tables. And practicing scientists, by and large, know that. But all of there's so many of the sort of the general quantification of science and of bibliometrics has made it harder and harder to remember, and all the rewards are sort of pushing us in the wrong direction. So I think, when I'm talking to people that I'm involved in mentoring, I really am focusing on the importance of how are you, not story in terms of a close, tight, completed story, but story in terms of how is the stuff you're doing interfacing with an ongoing story? You're one character in a quite complex screenplay. What are you doing that is integrating yourself into that screenplay and propelling it forward? And because that's, I think, what we're fundamentally doing as scientists. You can't do science in a room by yourself. Doesn't matter how smart you are. It's not science until you get out and communicate and share and build on things other people are building. And so, again, I worry, I talk about LLMs interposing themselves between authors and readers, and I see them interposing them, and we're, of course, both as scientists, but they interpose themselves between us. And so I do see it as this dehumanizing force, and now we're back to sermon, but that's, I don't know, does that answer your question at all? Yeah, thank you.
I don't know if it's a question really that I want to ask,
sure,
but
of course.
in what you have described, which is very interesting, I see something missing.
Okay, yeah, sure.
To me, the quality of a paper is not just how it's written. It's the creative part that comes in. Mm-hmm. And that's not something that the LLM can give. So it's not something that you can quantify the way it seems to me it's not accounted for. This LLM can, so it's not accounted for. On the other hand, it seems to me it's neglecting what you showed, the utility of the LLM as a tool to make your new ideas clearer. Am I making myself clear?
Well, I think
I see it from let me just finish.
Oh, sure.
Just one sec. I see it from the perspective of obviously not a native speaker. LLM can help in making ideas clearer. Of course, it's not used to develop new ideas.
I think that's really useful. I mean, so on one hand, the model. I mean, I tried to explicitly concentrate only on the act of writing for the model. So this is only a model of writing. And that's why I said I was going to back off and just do writing. So this is just a consequence of it removing one particular friction from the process. There's other frictions maybe it's not useful for, or it is useful for, or whatever. The non-native speaker argument is a very good one, and one of the strongest arguments I see for these systems. My Spanish is terrible. I can read it, but I'm a terrible writer. And if I had to write in Spanish, an LLM I know can write much better than I can in Spanish, and that would continue to be the case for decades if I were to try to write in Spanish. And so that is I mean, we want to identify the upsides of LLMs, and we want to point to those and bring that out. At the same time, what I see is it's not the non-native speakers that are the biggest boosters and proponents of LLM writing science. It's my colleagues that are running massive labs that are publishing 35, 45 papers a year and can't be bothered to, edit a graduate student's discussion section.
May I respond? I think perhaps that's a biased conception, because right now most of it is run here because perhaps we haven't been able to see what's coming from other places because it never reached the surface, because it wasn't written well enough. Just
So I'm the type of person who I have a really hard time disentangling writing from thinking.
Yes.
And I realize there are a lot of people whose brains don't work that way. And one of the most fascinating things, I think, is to try to get people to express to me in language how their brain works when they don't think they're writing. But my knee-jerk reaction when you made that comment about, someone can't be bothered to edit a discussion section was that, that's a dereliction of duty on the, and someone really taking their privilege as a PI with a highly functioning lab and hoarding that privilege and not helping those around them. Because fundamentally, these things are apprenticeship models of learning.
Yes.
And we have to do that apprenticeship. And so when I was seeing your figures, I remembered, Henry David Thoreau, the great solipsist, right? Someone was doing his laundry.
Yeah.
He didn't do that because he was doing all the work of living.
Right.
He could live the way he lived and write the way he wrote because someone was doing his laundry.
That's right.
And I think that looking at how you framed that, you've accepted the frames of, production counts, process doesn't. And it would be wonderful to see the opportunity costs or the other ecological values of educating the team that you're doing team science with introduced into the figures that you presented, which I think tell a powerful story, but leave a lot of things out and accept a lot of frames, which I think are problematic.
That's useful. Yeah, I guess I need to get a better sense of, what the true incentive structure is. I was trying to represent the incentive structure in as I see it, but there are many of my colleagues who, of course, take most of their job satisfaction from things that aren't in these figures, and that's a very fair critique.
So first, I just want to appreciate that the way in which you're using foraging theory is illustrative, and that the assumptions you're giving up front are to illustrate your points, and you're not making a commitment onto what's happening on the ground. So just want to point out that my curiosity, and also too, since you're coming from a biologist background that can be more in your vocabulary, I'm just thinking about economics as illustrative examples and how they can really change in what toolkit you can use. Particularly if you were to put this in a game theoretic language,
Sure.
as opposed to this being a question of energy expenditure, to make this a question of what type of impacts happen in a pooled set of resources in a community, because you're outputting and there's other people interacting with it, there's signaling and whatnot, to what extent you're able to outline the dynamics of science as a process, as a culture, as a team-building activity in a game theoretic language, as what Dave was alluding to with gatekeeping, for example, and whatnot. If that's able to perhaps get more at the crux of what you're discussing?
Quite possibly. I mean, this paper is a little unusual for my work in the new economics of science in that it's not game theoretic. This is just strictly optimization theory. And I was a little embarrassed about that coming out here, but it was the only thing I had on AI, so I was kind of stuck with it. As a first approach to that, short of writing out the math, I guess I'd start by thinking about externalities. If I want to think about the game theory of this and say, what are the positive and negative externalities that are getting generated by different elements of this entire process? So, and that might, for example, that might help you draw out the story around whether it's good that those papers are getting published that wouldn't have gotten otherwise published, right? Is that, in one story, that's a positive externality. We've had a lot of effort to try to, promote registered reports so that null results get published. It's just, publishing stuff that people can't be bothered to write up and tying journals' hands into publishing it is good for the community, so positive externality. On the other hand, I feel very strongly in my field of theory that there's way too much getting published. And so that that publishing volume is generating negative externalities for everybody because there's a common pool, if you will, of attention, and people are being greedy about it. And there's no way for me to sort through the volume of nonsense that people are putting out. And so I'm personally a huge fan of various forms, I suppose, of gatekeeping that involve trying to incentivize people to publish fewer, better papers. So I think that would probably be where I would start to try to think about this in a game theoretic perspective. The other place I would look at would be, and we've done some of this modeling for high risk, high return stuff. We've got a paper in review at a philosophy journal right now that's a game theoretic model that looks at how the competition for prizes, competition for faculty slots and things like that shapes research strategies around risk levels. So you may have to do riskier research if you have to clear certain bars in order to get a faculty position, for example. And so you may have actual mismatch on a research team where you have a faculty member who needs tenure and therefore needs 5 papers a year, but they can be in PLOS 1, working with a postdoc who needs a first author Nature paper to get a faculty position. And so you have these sources of tension that people haven't explored before. Once you take into the game, that only arises in this game theoretic context where you actually have competition. So that would be a couple of places where it would come in. I don't have any snap answers to like what happens here, or else I probably would have tried to stick it in the model and sneak it past you.
Yep, just for future directions.
Yeah, thank you.
Hi, thanks for the presentation. I was just curious, if you had two worlds, say, one where Eric Schmidt's AI scientist like worked perfectly, it was producing great science, and another where, you know, like after this meeting, all these scientists go out and start a movement, no AI science, you know, and it doesn't happen. If you were going to be born into one of those two worlds and you didn't know which position you would end up in either of them, you could be a scientist, you could be a non-scientist, a civilian, which one would you choose?
Yeah, you know, veil of ignorance. I'm not sure. I think I would choose. I mean, I'm biased here, but I think I would choose the one with. So I first of all, I deny the premise that that Schmidt's agent is doing science, because science is a collective human activity. Schmidt's agent is doing some kind of technology data collection. Okay. And I want to live in a world where people do science the same way they do art. And I spend a lot of time consuming science that is not part of my professional life. So, you know, for various reasons, I've had a big block of time and have delighted in trying to understand general relativity and some of its implications for early cosmology. I'm never going to publish in these areas. I'm not smart enough to publish in these areas, but I take delight in living in a world where humans are doing this, just like going to a museum. And so I think I would choose that, but I don't know if I'm just saying that so I can, you know, say something bad about Eric Schmidt's vision. I mean, I want a cure for, you know, childhood leukemia too. So, you know, if Eric Schmidt's going to get us there, maybe we want the two tracks in parallel. I don't think he'll get us there. But.
Well, so this is a very natural follow-up to exactly what you said, is that obviously it's very nice to live in a world where humans do science, but if we are assuming that AI-driven, call it what you will, quasi-science, schmience, right? Yeah. Schmience works, but it's sort of delivering vaccines, it's delivering, you know, clean water for the whole world, providing a solution to climate change. I mean, I'll take that. Well, I'll be a little bit sad. No one's stopping me from reading the GR textbooks, but I mean, I'll take that any day of the week. Mm-hmm. And I'm just a little bit concerned that somehow we're losing track of the actual social value that scientific or schmientific achievement can give us, right? That isn't just the nice communal aspects of having people think deeply about deep questions, which, by the way, I'm completely on board with, but yeah.
Well, I mean, I guess if we want to take that fantasy really, really seriously, sure. I mean, I think it's kind of...
that was the opening premise of your non-sermon half of your talk, right? Like, assuming that it sort of works out.
I was assuming, well, let's see. So, I mean, I was assuming I wasn't assuming that you have end-to-end science. I was assuming that they can do one particular thing as well as we can, right? That was it. Okay. My personal view is that, you know, you can ask these counterfactuals, you know, what if you never got hungry and God gave us all a pony? Great. Sure, I'll take it. But that's not, you know, Eric Schmidt's not going to deliver that, and neither is God, I guess.
So fair enough, but my question is perhaps more on the margin, right? So sorry, this question is perhaps coming out more hostile than.
No, it's not certainly not interpreted that way. So, I'm just trying to think through it.
So on the margin, right? Like you were saying, like we have a choice at the end, you know. So to take the final analogy you ended your talk on, the driverless train.
Yeah, the driverless.
So you take driverless cars. If they are going to get accident rates down dramatically, I enjoy driving as much as anyone, but I'll still take a much lower accident rate. So on the margin, we have to make these choices, whether we want to keep the sort of nice things we get by being able to do these things? Or do we accept that perhaps some of that is going to be lessened, but we get other benefits, and some of those benefits are quite serious?
I mean, I think, you know, if you want to carry through the counterfactual in all of the best case scenarios, I'm totally with you. I think when you try to carry through the more reasonable versions of that counterfactual, you have to ask, who is the AI scientist serving? How well is it representing a diversity of views? What are its aims? What is it doing for, humanity? What is it doing to the concentration of wealth? All of these kinds of questions, right? I'm profoundly pessimistic about the answers to all of those. So I think that's probably getting in the way of me fully embracing the counterfactual.
Additional questions that people have? Okay, well, if not, please join with me in thanking Carl.
Thanks, everyone.